Welcome to the deep dive. Today we're taking a look at a piece of hardware that you could say is the definition of unseen critical infrastructure. It's the Thor broadcast F-32CC-TxRx, and its job is pretty simple on the surface. It takes basic ONOF commands and sends them over fiber optic cable. Our mission today is to figure out how this technology makes sure our vital systems work perfectly no matter how far apart they are. Okay, let's unpack this. What exactly is contact closure? And why does such a simple signal need something as advanced as fiber optics?
Right. Well, the fundamental job here is basically industrial remote control. It's actually deceptively simple. When we say contact closure, you should literally think of, say, a light switch or a doorbell button. It's an electrical switch. You physically short two pins on the transmitter side, and that action instantly closes the circuit on the receiver side miles away.
So it's the most basic signal you can have. A circuit is either on or it's off. Simple. But the source material also mentions 5 VPP TTL pulses. Is that just a more technical, sort of standardized way of saying on?
Precisely. It's the industry standard for a really clean, noise-immune digital signal. And this kit's specialty is taking 32 of those signals, so 32 separate remote switches, and just bundling it all into one package.
32 channels in one box. That's
Yeah.
a lot of efficiency. But if the signal is so simple, why couldn't you just use copper wire? I mean, what happens if you try to run 32 pairs of copper for, say, a few miles?
Failure. That's what happens. Signal degradation, noise.
Yeah.
It would be a disaster. Copper lines lose signal over long distances, and they act like giant antennas for electrical noise. It's why this has to be fiber. You can push these 32 channels up to 20 kilometers over single-load fiber.
Wow, 20 kilometers, that is an immense distance. And since we're using light, not electricity, you basically just eliminate all the common electrical problems, right?
Absolutely. Things like EMI and RFI, electromagnetic and radio frequency interference, they're just gone. Not an issue. But maybe the biggest problem fiber solves is something called ground loops.
Ah.
If you run copper between two buildings, say a mile apart, tiny differences in their electrical grounds can cause all sorts of voltage problems. Fiber just isolates them completely. It doesn't care about ground differences.
And the hardware itself is built for that same level of reliability. The specs say it's plug and play, no optical adjustments needed, and it barely uses any power, less than 3 watts.
Which is incredible when you consider the environments this thing has to survive in. The operating temperature range is just massive. We're talking from a freezing -20 degrees C all the way up to a blistering +75 degrees C. This hardware is built for the absolute extremes.
And if you want a metric that really sticks with you, the reliability is quantified with an MTBF, a mean time, between failures of over 100,000 hours. To put that in human terms for you, that's more than 11 years of continuous operation without a single fault. Here's where it gets really interesting. Why do you need on-off switches that are this reliable, that can go this far and survive for a decade in extreme weather? Because this is the invisible engine driving systems we rely on every single day.
It's the foundation. Take building automation. A single one of these units can be managing, say, a dozen access control gates.
Yeah.
And at the same time, it's handling the HVAC systems for different zones across a huge complex. It all has to work perfectly.
And then you get into the really high-stakes stuff, access control for secure facilities, large-scale fire and alarm systems where that signal has to get through instantly.
Exactly.
Yep.
And PIR signal transmission for security systems. You also see it playing a huge role in public safety. Maybe the most visible example is traffic signal control equipment.
So that's the mechanism making sure that triggers happen instantly and flawlessly across, huge complex intersections.
That's the one.
So what this all means is we're looking at a single, pretty unassuming kit that uses light to give us 32 guaranteed instantaneous remote switches. And those switches form the backbone of these massive mechanical and safety systems that really affect all of our daily lives.
And that raises a really important question, I think. Given this device's ability to work perfectly in that huge temperature range, from blistering heat to freezing cold, and with that reliability over 100,000 hours, just consider for a moment the real cost, the true consequence of a failure in something like a traffic signal system. What unseen hardware, built to last over a decade out in the elements, is managing the safety of your daily commute.